A very good morning to you all. Good morning.
Morning, sir.
Yeah, we had talked about circles touching last time. And one of the reasons, or one of the ways we could confirm that they touch was the distance between the two circles. But there's another condition also I want to talk about that shows that circles can touch, especially externally, whereby this is my circle. And this circle is touching with another circle. Then these circles ideally have a common tangent. So they have a common tangent which combines the two circles. So this is still circles touching. And I've called this a common what? Common tangent. Remember, the first circle can have a center C1, the other can have a center C2. Last time I talked about the distance between the centers, that is the radii, should be the same. I mean, it should not be the same, but should be added together to give us the distance C1 and C2. Okay, so, but now I want to show you another condition you can use to prove that these circles are touching and they are touching externally. So the first method we had seen was C1, C2 is equal to R1 plus R2. This was showing that they touch externally. Now, the second method, because we have seen they have a common tangent, then we can show that they have a common tangent and even can find the point of contact using that very tangent we have. Now, for example, consider two circles. Consider two circles. X squared plus y squared minus 6x minus 2y plus 1 is equal to 0. And x squared plus y squared minus plus 2x minus 8y plus 13 is equal to 0. Show that the circles touch each other and find their point of contact. They touch each other externally and find their point of contact. Now, according to that question, we have two circles. And these two circles, we can ideally see that these two circles are touching each other. And I have said they are touching each other. We solve them simultaneously. By elimination. Elimination. How? X squared plus y squared minus 6x minus 2y plus 1 is 0. Then x squared plus y squared plus 2x minus 8y plus 13 is 0. Now, when I'm solving them simultaneously, this is, remember, knowledge of senior 2, how we solve simultaneously, by subtracting. So you subtract, and then you get 0 plus 0 minus 8x plus 6y minus 12 is equal to 0. So you get 6y minus 8x is equal to 12. This is 3y minus 4x is equal to 6, is the equation of the common tangent. So this is the equation of this common tangent, this red line I drew earlier. Now that equation of the common tangent, you have to go ahead and make it the subject. Okay. If you make it the subject, what is it going to be? Okay, I chose this question, but it's okay. Let us just investigate. I'll conclude. If y is made the subject, you'll have y is equal to 6. No, let me just leave it like that, because this is going to be a little bit longer, but okay. So you make y the subject and say 6 plus 4x divided by 3. Call it equation star. Then substitute star in one of the equations and say, for example, x squared plus 6 plus 4x over 3 squared minus 6x minus 2 of 6 plus 4x out of 3 plus 1 is 0. Then you design an equation in terms of x and solve it quadratically. So you'll get x squared plus 36 plus 48x plus 16x squared all is over 9 minus 6x minus 12 minus 8x over 3 plus 1 is 0. When you cross multiply, you'll get 9x squared plus 36 plus 48x plus 16x squared minus 54x, multiplying everything by 9, minus 108 minus 70. No. This is not 108. 108, I was multiplying 9 by 12, but actually there is a 3 down. So the LCM of 3 and 9 is 9. So when you divide 9 by 3, you get 3. So 3 times 12, you get a negative 36 minus 24x plus 9 is 0. Collecting like terms gives me 25x squared. 48 minus 54. This is 72. 72 minus 54, what do you get? There's a balance of what? There's a balance of 6. 6 plus, from 6 to 72, 12, you get 18. So plus 18. X, I can lose the 36, and I'll remain with the 9 is equal to 0. Can you get me these two values? So I had forced myself to have this word externally. Let me remove it. So what do you get? X is negative 0.36. Elizabeth has given us negative 0.36. Another one?
It's repeated, the same answer.
Repeated, very good question. Very good. I was about to quit the number, but it has given me the picture I really wanted. Now, when it gives you a repetitive word value of x, which is 1, it confirms that it touches it at one point. That is 1. That is confidence that it touches, because it touches at one what? At one point. Hence, since x is repeated, comma, then the circle does what? The circles do what? Touch. each other at one point where x is what? Negative 0.36. We understand that? I was worried that it might give me two different values. When it gives us two different values, it is the next definition we are going for. When it gives us two different values, the circles intersect. Okay? So it is what is coming next. So here they are asking us to show that the circles touch each other. So we have shown by going ahead and use the tangent, which is the equation of the common tangent. You substitute it in one of the equations of the circles, then you solve the quadratic you have designed. That quadratic will give you a repeated root. When a repeated root is given, it means the circles are touching. When you get two different roots, it means the circles are intersecting. Okay?
Sir, I beg your pardon on what you.
Yeah, I have said, if the circles are touching each other, okay? If these two circles are to touch each other, then they are touching each other at a common point here. There's that one common point where they are touching each other. So after getting their what? Their common tangent, which is touching both of them at that very point. That common tangent, when you substitute it, the equation of that tangent, when you substitute, because ideally you are solving the tangent simultaneously with one of the circles. So you solve the equation of the tangent simultaneously with the equation of the circles. So when you get the equation of the tangent, and then you solve it with one of them by substituting or making y or x the subject and put it in one of the equations, you will get a quadratic, either in x or in y. But when you solve that quadratic, and it gives you two possible values of x, which are different, then this is what it's going to mean. I wanted to bring it in the next definition, but let me bring it now. It brings two different points. If it brings two different points, this is what is most likely to happen. It will show you that you're actually having two different x values, whereby one x will be up here, another x will be down there. And therefore, this equation you would have got when solving simultaneously will be called the equation of the common chord, not the equation of the tangent like we had it before. Remember, before you had the equation of the tangent, but now, in case the values are two and they are different, then this one becomes the equation of the common chord. This becomes the common what? Common chord. But according to what we had, this one was being called the common what? Common tangent. Now, if the values of x you have attained on solving are the same, then they confirm that the circles do touch each other at one point of contact using the common tangent. If you get two different values of x, x1, x2, then the circles intersect. And the line joining those 2 points is what we call the line of the common chord, like we are going to see. Has that made some sense?
Yes, teacher.
Okay, let me give you another.
Excuse me, teacher. I'm requesting you to repeat for me. The common tangent.
Okay, let me do this now.
The
Let me
common
give another
tangent
example.
and the common chord.
Let me give a common tangent, another example of a common tangent. Find the equation of the common tangent of the circles x squared plus y squared plus 3x plus y is equal to 0, x squared plus y squared minus 6x minus 2y is equal to 0. Hence, find their point of contact. So, Ukasha, I'm coming in again with your explanation of what you needed. We are assuming these are our circles. Remember, even if you don't draw sketches, but for interpretation and explanatory purposes, we can have the sketches down. If this is our circle, and this is another circle, and these circles are touching each other very well, they're asking us to find their common tangent. So to find their common tangent, we said we solve them simultaneously. Okay, so how do we solve simultaneously? X squared plus y squared plus 3x plus y is 0. Then we have x squared plus y squared minus 6x minus 2y is equal to 0. When we have those two equations, then we are going to have the following. We shall have to solve simultaneously by elimination. So you eliminate, we shall say subtract. You'll get 0 plus 0 plus 9x plus 4y, 3y is equal to 0. So 3y is equal to negative 9x, y is equal to a negative 3x. This is the equation of the common what? Common tangent. So if that is the equation of the common tangent, then we can use that equation and substitute in one of the circles and find the point of contact. How do we go by that? Choose, for example, the second one. X squared plus 9x squared minus 6x plus 6x is 0. I vamoosh. I'll get 10x squared is equal to 0. My x will be 0. My x is 0, definitely also my y will be 0. So the point of contact is 0, 0. So here, one may say, how have I known that here I've got two values of x which are the same? You remember, you get, this confirms that x squared is equal to 0. X squared, remember, is a quadratic, having two possible values of x. So the two possible values of x, however much x squared is 0, are still 0. So they are two repeated values of 0. So x is 0, but you always have to note this, that this is what? Repeated, to help you know that there are two possibilities of having two values of x, but you've got one value of x which has the same value. When you get one value of x which has the same value, then the circles touch each other. When the values of x are different, then the circles intersect. Kash, have I made that clear now?
Okay, sir, thank you. What was for the code?
Don't worry, it is what I'm introducing next. So intersection of circles. Pardon?
How did you get the last equation?
How did I get the last equation? Which one?
X squared plus 9x, that one.
Okay, okay. I told you, when you get the equation of the common tangent, solve it simultaneously, either with this one or with this one, because it behaves like this. It looks like this one. If this is the circle, and I have the tangent, and I have a tangent touching the circle. To find that point of the contact, I did this earlier. To find this point of contact of the tangent and the circle, you solve this equation, which is y is equal to mx plus c, and solve it with x squared plus y squared plus 2gx plus 2fy plus c0. So you solve the two simultaneously by making this y the subject and you drop it where y is all through. Then you have a quadratic in x. So what I've done, I've got the negative 3x and I dropped it here and I dropped it there and I realized that one. Okay. The same knowledge is coming back to intersection. Hope I've made myself clear there. So here we can say circles normally intersect. Normally intersect on a common chord. On a common chord, which is obtained by solving two circles equations simultaneously. Okay, so illustration for that, we have one circle here. And we have another circle here. See those two circles, they are intersecting very well. As they intersect, they get what we call a common chord. That is a common chord. That is the common chord for those two circles. They are intersecting here at A. They're intersecting here at B. Remember, they have their centers. Center C1, center C2. Okay. So I called this one the common what? The common chord. So two circles may intersect, but when one of the equations is subtracted from the other, the equation of the line is still obtained. But this line is not a common chord. This line is a locus of points x, y, which moves such that the length of the tangents from the P to their centers is equal. Now, anyway, there's something else. This is, I think, a note of something else which I want to read out, which I wanted to read out. That in case some circles do not intersect, but there can be a locus of points which can be equidistant from their centers. Yeah. So, but this first condition is for when the circles have intersected. Now, what if they do not intersect? That is our NB. NB circles may not intersect when what? But when one of the equations is subtracted from the other, like I've been showing you how we have been subtracting them. This is what I'm trying to show you. So you have one circle here. Then you have another circle here. And there is a point up here.
Excuse me, teacher.
Yes, please.
I request that you go back to the previous page. I just want to take a screenshot.
Okay. Okay. Then if you have an imaginary line that is coming through them, this imaginary line will be predicting a locus of points. Whereby this is the point. This is where P is. There's point B here. There's point A here. This one has center C1. This one has center C2. So I was saying, in this case, AP is equal to PB. So the note here says that this is our NB. Two circles may not intersect, but when one equation is subtracted from another, the equation of a line is still obtained, just like we have been getting the equations of the line. But this line is not a common chord. Now, the two circles, if they are not intersecting like the ones we have been seeing before, they may not be intersecting like these ones before. These ones are clearly intersecting. I think you can see this part very well. Yeah. Now, what if you find the common chord and you subtract them, but when these circles are actually not touching each other, then they will describe a locus of points. That locus of points will predict a line, which line I'm showing you according to this illustration. So this is the locus of points from P. Now, in that sense, a locus of points, which is a line, is still obtained, but this line is not a common chord because this line is not cutting through any of the circles. That is why we are saying it's not a common chord. This line is a locus of points of a point P, which moves such that the lengths of the tangents from P to their circles is equal. So let us have that written down. So we can say, according to this NB, two circles may not intersect, but when one equation is subtracted from another, the equation of a line is still obtained. The equation of a line is still obtained. But this line is not a common what? It's not a common chord. So if this line is not a common chord, what is it? This is a locus. This is a locus of a point P, which is XY, which moves such that the lengths of the tangents from the point P to their circles is always equal. So one may say, but teacher, when I subtracted the two circles, I got an equation of the line. But when you substitute the equation of the line, does not satisfy the condition that these circles either touch or intersect. Then it will be just, the line will be just predicting the locus of the line, whose distance is always the same from the variable point P to the tangents where they touch the circles. An example. Examples of intersecting circles. Show that the common chord, of the circles x squared plus y squared is equal to 4, and x squared plus y squared minus 4x minus 2y minus 4 is equal to 0 pass through the origin. Pass through the what? The origin. Now, they're asking you to show the equation of the common chord of the two circles. So when they say that, just know that those circles are intersecting. There is no way they are not intersecting, and yet they're mentioning they are intersecting. So straight away treat them as if they're already intersecting. Now they want you to confirm and find the equation of their common chord. Now, like we have said, we have to subtract them simultaneously. Or a smart student will see that since you have x squared plus y squared is 4, and the other equation also has x squared plus y squared minus 4x minus 2y is equal to 4. One who is very smart, you don't need to subtract. But let us first start with our way we have been handling. So we get 0, 0 plus 4x plus 2y is equal to 8. Wait, do we get 8 or we get 0?
Just 0.
We are getting.
Yeah, am I bad? So it means y is equal to negative 2x. The moment you don't have a constant, the chord passes through the origin. Because when x is 0, y is also what? 0. So they have said, show that the chord passes through the what? The origin. So since y is equal to negative 2x, hence the chord passes through what? The origin. The other solving skill I wanted to show you is for substitution. That in case you have seen that this is x squared plus y squared is 4, get it and put it here. And say 4 minus 4x minus 2y minus 4 is 0. You are a steady machine in algebra. You don't waste time. Answer, finished. Find the coordinates of the point where the common chord of the centers of the circles meets the line joining their centers. Very good example. Okay, screenshot that. I go to the next page and we have this last example. This one, then we conclude the last definition on circles, which is orthogonality.
So how do you know if the chord passes through the origin?
How do you know? Have you seen the equation of the line y is equal to x? Or
Yes.
y is equal to negative x? What do you know about it?
If it passes at 0, then if y is 0, x is 0.
And where is that point?
The origin.
It means the intercept is 0. Do you agree? Let us go back to some coordinate geometry. If the intercept is 0, it means the curve is not cutting any other point. That line is not cutting any other point of the axis. It has to cut the origin only. Whenever the intercept is 0, yeah, the line passes through the what? The origin. Okay?
Yes, sir. Thank you.
Okay. Okay, very good example coming our way. People should be very attentive on this example. It says, this is example 2. Find the coordinates of the point where the common chord of the circle x squared plus y squared minus 4x minus 8y minus 5 is equal to 0, and x squared plus y squared minus 2x minus 4y minus 5 is equal to 0. Someone may say, but teacher, all the numbers you're doing have x squared, y squared. If one circle has 2x squared, 2y squared, make sure the coefficients are the same. Methods of solving simultaneous equations. You either multiply through or divide through. But the essence is to eliminate x squared and y squared. So how you eliminate it, it's up to you. If the equations do not have coefficients on them at their highest degrees, make sure that also the other has the same highest degree. Yeah, I wish I could learn on an example of that category, but I don't know. But that's what I wanted to chip in for that. That some people might worry and say, but teacher, how do you eliminate when the values of x squared and y squared in the equations are different? You make them the same. Elimination method, right? So with that, meets the line joining their center. I sent you numbers and I expected to see those numbers. I wanted to mark them actually, but none of you sent me any solution. I sent you very many numbers on circles, numbers on, So please, I expected you to send them. Now, here is this question. Now, this is why we sometimes need a model to see how the shape or what the question is actually looking for. Now, you hear what this question is saying. The question says, find the coordinates of the points where the common chord, which one? This one. Does what? Meets. This is our common chord. What is it going to do? It is going to meet the line joining the centers of the circles. Someone's in my chat. We know the teacher always should do simple ones and give us the blood ones. I know which simple ones. Look at this man. Man, me, I did my hard ones in my time, so you better do yours. Opio Andrew, better do your hard numbers. Yes. You think that's what it is. When you come to the real life of working, you must find your way out. That's why some people say, for us, we don't see the use of what we studied at school in our day-to-day activities because they are not working hard. Now, this is what the question wants. The question wants us to find this point P. This is the common what? Common chord. So get the equation of the common chord, get the equation of the centers, and solve simultaneously. So to start with, we know x squared plus y squared minus 4x minus 8y is equal to 5a. Then we have x squared plus y squared minus 2x minus 4y is equal to also 5a. Okay, they are both equal to 5a. When we eliminate, what shall we attain? We shall attain a negativity of 2x, a negativity of 4x, of 4y is 0. Thus, y is equal to a negative RF x. Meaning the common chord also still passes through the origin. Why? Because it has no intercept. Now, having confirmed that, the question went further and said, solve the equation of the centers. So the centers, we know the centers of our circles. Center C1 has what coordinates? 2 and 4. Why? You divide the coefficient here by -2, the coefficient here by -2. Then center 2 has what coefficients? 1 and 2. We agree? So for that reason, we can find the equation of those two. Get their gradient m, which is change in y out of change in x. And this is going to give me 2. So y minus 2 out of x minus 1 is going to be equal to 2. And with that reason, y minus 2 is equal to x minus 2. Vamush, vamush, y is 2x. So if y is 2x, when you solve them simultaneously, you definitely see they give you 0, 0.
Excuse me, sir.
Yes, please.
Sir, I've not got how we got like those centers.
Yeah. Do you remember how we get the center? If the equation is x squared plus y squared, give me the general equation of the circle.
Minus 2dx.
We had said we agreed to use 2 plus.
Minus.
Okay. So you divide the minus 2g by negative 2, the minus 2f by negative 2. The center is gf. So you divide the coefficient on x with each sign by negative 2. Divide the coefficient on y with each sign by negative 2. Then you get the center. The other methods are completing squares. Those ones are longer method, but that is a quick one. So the lady was asking, I don't know that you got that.
Yes, I've got it.
So when you solve these two equations simultaneously, so this is equation 2, this is equation 1. When you eliminate, you get 2x plus a half x is equal to 0. So x is 0, even y is 0. So those two lines meet at 0, 0. So questions will be coming in different formats as they are being set. Okay, the last condition, the orthogonality condition. And the orthogonality condition is talking about what we call orthogonal circles. Orthogonal circles. Now, two circles are orthogonal if and only if two circles are orthogonal if and only if, yeah, they intersect at right angles, i.e. 90 degrees. So how do they intersect at right angles? If I have a circle, this one, and I have another circle, this one, and these two circles, a tangent coming from here, and a tangent coming from this one. Those two tangents should form 90 degrees. And then this line joining the two tangents, their centers. So one, this angle should be 90. Two, there is center 1, there is center 2. Okay? Now those centers, from center 1 to point here A, there is a radius R1, then there is radius R2, then there is the distance between the two centers D. So when you extract out that right angle triangle, it will take on such a shape. When you extract it out, it will be like, this is 90, and this is A, and this is C1, and this is C2, and this is D, and this is R2, and this is R1, then D squared is equal to R1 plus R2 but both of them are squared. That is using Pythagoras what? Theorem. So the condition for orthogonality is the square of the distance between the two centers is equal to the sum of the squares of their radii. The square of the distance between the two circles between the two centers of the circles is equal to the sum of the squares of their radii. Okay. Should I do the derivation? There's a derivation I want to do, but we can even do away without this derivation. But let me derive. Because according to that definition, it's very easy. Even if I don't finish it, you can try out an example on your own. But today we have to finalize circles, so that next week I introduce a parabola. If I'm done with the curve, I need 2 more lessons for the curve. I'll introduce another conic section so that we do all of them drastically. The question says, not a question, but it says, considering two circles, x squared plus y squared plus 2g1 of x plus 2f1 of y plus c1 is 0, and x squared plus y squared plus 2g2 of x plus 2f2 of y plus c2 is 0, that are orthogonal. So we are assuming these two circles are what? Are orthogonal. Then, for the first circle, x squared plus y squared plus 2g 1x plus 2f1 y plus c1 is 0. This circle has a center C star, which is a negative g1 and a negative f1. I hope my girlfriend, who asked me that question before, she now knows how I'm getting the what? The center. Then for the second one, the second center, C2 star, is going to be a negative G2 and a negative F2. Now, if I want to get the radii, radius R1, remember it's got from G1 squared plus F1 squared minus C1 under the square root. Then radius R2 will be root of G2 squared plus F2 squared minus C2. Then having confirmed those two, we can be in position to go ahead and also get D. Remember, D is C1 star C2 double star magnitude. So in that sense, what is C2 and C1 double star? We have seen, let me show you this with illustrations. We have seen that if these are our centers, these are our circles, we have confirmed that we can have a line joining our two centers, C1 and C2. We can have their diameter, tangents, coming in from there. We can have also this one coming in from up there. And also recall, this is supposed to be what? 90. So this is C1, this is C2. We have seen C1 is negative G, negative F. C2 is, this is G1, F1, negative G2, negative F2. So this is R1, this is R2. So to get D, D is here, remember. So D is going to be equal to the magnitude of the square root of G2 minus G1 squared plus F2 minus F1 squared. But remember the definition is D squared is supposed to give us R1 squared plus R2 squared. So when you substitute, you'll have G2 minus G1 squared plus F2 minus F1 squared is equal to the square of R1 and R2 is G1 squared plus F1 squared minus C plus G2 squared plus F2 squared minus C2. This is C1. Okay, so when you do that, what will we attain? We shall attain the expansions come in handy, which is giving us G2 squared minus 2G2 G1 plus G1 squared plus F2 squared minus 2F2 F1 plus F1 squared is equal to G1 squared plus G2 squared plus F1 squared plus F2 squared plus minus C1 minus C2. You vamoosh all these by subtraction. Therefore, if all those are vamooshed by subtraction, remain with a negative 2 of G1, G2 plus F1, F2 is equal to a negative C1 plus C2. So in totality, twice of G1, G2 plus F1, F2 should give you the sum of the constants in the equations of the circles. This is another condition you can use for orthogonality. So you can also show that if I multiply the x value of the center of one circle and the x value of the center of the other circle, plus the y value of the center of the other circle and the y value of the center of the other circle, and I add the two and I multiply them together, those values should give me the sum of these two values. This one and that one. So whichever way, whichever method you want is what you will use. So I've given you both methods, okay? So let's have an example. Unless if someone has a question. But I trust most of you are going for the first one. Rarely do people want to go for alternatives. Wow. Elizabeth is happy. Okay. Show that the following circles are orthogonal. Show that the following circles are orthogonal. X squared plus y squared minus 6x minus 6y minus 8y plus 9 is 0. And x squared plus y squared is equal to 9. First and foremost, we should get the center 1. Center 1 is 3, 4. Center 2 is 0, 0. Whenever we see this simplest circle, the center is at the origin. Eh? So we have the center. Then get radius R1. Radius R1 is going to be got from square root of 3 squared plus 4 squared minus 9. This is going to be 16 plus 25, which is 4. Radius 2, because we don't have the center is 0, 0. Okay, you get the square root of 0 squared plus 0 squared minus. Oh, now this is a minus 9, so it becomes a plus 9. So the answer is 3. Those who can't see for this one, you can write it in this form: x minus 0 squared plus y minus 0 squared is equal to 3 squared. What is always here is the radius. Eh? So can you prove whether this squared is equal to R1 squared plus R2 squared, of which this is 3 squared plus 4 squared is equal to 25. So show that D is 25, and D, remember, is C1, C2. So can we find C1, C2? C1, C2 is going to be square root of 3 minus 0 squared plus 4 minus 0 squared. C1, C2 is actually equal to is equal to 25 under the root, which is our D. So when you square the D, you definitely get 25. Hence, since D squared is equal to R1 squared plus R2 squared, the circles are what? Are orthogonal. Circles are orthogonal. Should we try out also the other scale? The other scale says twice G1, G2, a plus, F1, F2 should give me the center, the C's, star plus C, star double 2. These C's are the C's in the equations, so we shall get twice of, when I add the 2, what do I get? G1 times G2, you get 3 times, which is 0, 0, plus F1 times F2, which gives me 0, 0. Is it equal to a negative 9 plus a positive 9? Yes. So whatever you find cheap is what you use, but you state the equation which you're using to define the orthogonality condition. How many minutes? 12. We have finished 12. We have 12 minutes for free. Our learners should also check and see that the world is not easy. Show that the two circles are orthogonal. X squared plus y squared minus 4x plus 2 is 0. And the other circle is x squared plus y squared plus 6y minus 2 is 0. Please try that one now. Last time I sent you to UNEB, I don't know whether people got the numbers. Yeah? Someone should have posted for us those numbers. Let me write the numbers again. UNEB 2018, number 5. 2017, number 10. 2014, number 10. 28, question 9. 26, question 13. 25, question 9. 1999, question 9. Unless if someone has a question, but please do that number right now. We leave when you have done the number. So we first confirm the answers people have got. So you get the answer, you post it on the group, and I take a look and I mark it from here. Yeah, Gaba. Gaba, now why are you typing the procedure? Do the number, send me the number on WhatsApp. Send to the group and we take a look. Now it's just typing 2 brackets, 2 power 0 plus 0 power 3 minus 3 is equal to 2 minus 2.
Excuse me, sir.
Hmm.
So could you explain this part where you said x minus 0 squared plus y minus 0 squared equals to 3 squared? I'm not getting it.
This one. What is one?
Yes, this one. The one you underlined.
The one I've this one, eh?
Yes, sir.
And Kakati, now there is this equation. The general equation of a circle is x squared minus x minus g squared plus y minus f. Is equal to r squared. Because the circle has a radius r to a point xy and the center is gf. So the distance between the center and that variable point p can be got from this relationship is equal to r squared. That's how it comes about. Now, if the g and f are 0, then it is x minus 0 squared plus y minus 0 squared, that is equal to r squared. That is why I'm saying x squared plus y squared is equal to r squared. That is normally what we call the simplest circle. So the simplest circle is always originating from the center, from the origin. So if it is from the origin, you'll see it as x squared plus y squared without the other linear parts. So that's how it comes about.
Okay, sir, thank you.
Teacher,
Mm,
have D is equal to C1, C2 is equal to root 13.
correct.
Excuse me, teacher.
Mm,
Shall I help pardon on that part of the concluding part where you said 2 into bracket 0, 0 plus 0, 0 is equal to? I don't know where the 0, 0 comes from.
we have said what?
2 into bracket 0, 0 plus 0, 0 is equal to
Hey,
negative
okay.
9.
This one, eh? Okay,
Yes.
and it say, hey, okay. I know I know why I said 0, 0. It is 3 times 0. Okay? And then 4 times 0.
Okay, thank you.
Okay. Because you're multiplying this G1 and this G2. Then this F1 and this F2. So they give you 0. Okay, any other concern? Today we should surprise Mr. Kabagam. Shouldn't find us here. No one has sent in the group. Okay.
So I've got the same.
You've got the same 13, eh? Should be 13 throughout.
Yeah.
Yes,
Okay, that's the
13.
right answer. Yeah, but I had some people here who had arrived. Okay.
The previous page.
People have 13. Yeah, this person has it right. Okay, someone has said previous page. I want the previous page where they were to surprise Mr. Kawagan. Okay, that's the page you want. Is that it?
To the other page.
There you go. Okay, if someone also is interested in this one. So today is marking the end of the first conic section, which is the circle. So very soon we are introducing the parabola. By all means, next week we shall introduce the parabola. So please, I need you in the beginning. That's why you see some people who are not here when circles were beginning, they got challenges. So please be here when I'm starting the parabola. You don't be there, you might fail to understand the parabola from the word you go. Whatever number that will come, you'll not be in the position to know. Just like you've seen here that there are some standard equations you should know for a circle, even a parabola, there are some conditions you have to know about it. So please attend the next lesson. Okay, with that, I think we can call it a day. Have a good day. Nice reading. Please solve any number, every number you land on concerning circles. Visit all the question papers, all the mocks, all the seminar numbers. Only 2 people ordered for the seminar books and mock book I told you for the questions I have. Only 2 people are interested. So when you finish the back house, you go to all those books, go to UPM, Understanding Pure Math, go to past papers, you name anywhere, any number you land on, you chew. Don't leave it unturned. Don't just say, hey, that circle looks interesting. You do the number. You still have the time. Time will come when you don't have time to solve any more number. Okay, so with that, have a good day.
Thank you, teacher.
Anytime.